A 0.2 kilogram mass is suspended from a spring, which is what we see over here. A 0.1 kilogram mass is suspended from the 0.2 kilogram mass using a thread of negligible mass. The system is in equilibrium and the thread is then cut. What is the upward acceleration of the 0.2 kilogram mass at the instant that the thread is cut? So let's consider a force diagram. For the 0.2 kilogram mass, the upward force from the spring would be 0.3 g, and that's because that spring is supporting the weight of both of those masses, so it should be equal to 0.3 g. We know it's in equilibrium, so upward forces equal downward forces. The 0.2 kilogram mass also has a downward weight force of 0.2 g. I'll just put that on the right. The 0.1 kilogram mass has a downward weight force of 0.1 g and an upward tension force. It's in equilibrium again, so the upward tension force should be 0.1 g to counteract this downward force that we have here. The tension throughout the spring should be constant, and therefore the downward tension force on the 0.2 kilogram mass should be 0.1 g as well. Now, when the thread is cut, the 0.2 kilogram mass still experiences a downward weight force of 0.2 g. That can't change. There's no more downward tension force because the string is cut. The upward force in the spring would still be 0.3 g, at least immediately after it's cut. And the reason for that is because as soon as we cut this string that we have here, the spring hasn't had a chance to unstretch yet, because we're looking at the instant that the thread is cut. So immediately after it's cut, the spring has not had a chance to unstretch. If it's stretched by the same amount, the tension in the spring should be the same as well. So 0.3 g upwards, and that leads to an upwards acceleration of, let's say, a. The resultant force would be then 0.3 g minus 0.2 g, so that will be the overall upwards force. So this is our F, that's 0.1 g, resultant force is then equal to ma, the m is 0.2, the acceleration is a, and when we rearrange this for a, we get a half g. That's just doing the 0.1 divided by 0.2, the g is still there. A half g is 4.9.